Today's lesson, section 7.2a, we're talking about addition and subtraction formulas. So here we're taking sine, cosine, and tangent, and we're adding and subtracting angles. Okay. Now, during class, I will show you how we come about finding these formulas, and give you a kind of an idea of how they came about. But we'll use these to help us evaluate expressions for certain angles that maybe they're not necessarily like on the unit circle, but they're not really like described on our unit circle. So like numbers that are in between pi over 3 and pi over 4, or in between pi over 6 and pi over 2, stuff like that, where it's not, we don't really know the point, but we can figure it out, or figure out the ratio using these formulas. So go ahead and copy these down. You have an addition and subtraction one for each sine and tangent. Okay, we'll also verify identities using these addition and subtraction formulas as well. So just know that we'll need them later on. Okay, so example 1, we want to find the exact value of the following. So letter A says the cosine of 15. Now, you can do this a number of ways. Now, because it says cosine, you need to use one of the cosine formulas, either addition or subtraction. Okay. Now, sometimes one is more obvious, like to use, than others, but some of them you could use multiple, like either one. So here, cosine. Now I need to figure out two angles that add up to 15 or subtract 15. That's kind of what your thought process is. So I need to figure out an x and a y. They either add or subtract to give me 15. Now, I want to use angles that I already know from the unit circle to help me out, because we don't want to just use random ones, because then I still won't really know what to do. So for 15, an easy one would be if I took 45 and then 30 and I subtracted the two, because 45 minus 30 gives me 15, plus I already know the angle measurements or the ratios for 45 and 30. So then I can use this to help me find cosine of 15. So now, if I go back to my formula, since I'm using a subtraction one, that means I need to take cosine of x times cosine of y plus sine of x times sine of y. So cosine of your x, so it's 45, times cosine of 30, that's my y, and then plus, now for the cosine ones, the signs are always opposite. For sine, the signs are always the same, like in between. That'll be one like kind of trick you'll need to remember to help you remember them. So sine of 45 times sine of 30. Okay, so cosine of 45 is a ratio that we know. It's square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Now remember, I'm just getting this from the unit circle. I'm not finding this magically. Sine of 45 is square root of 2 over 2. And then sine of 30 is 1/2. Okay? So now I want to simplify. Now that I have all numbers, square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Plus square root of 2 times 1 is square root of 2. And 2 times 2 is 4. Now I could leave it like this, or you could write it as one whole fraction. I think the answer key usually writes them as one fraction. Okay, but that would be my answer, because you can't really put square root of 6 plus and square root of 2 together. And there's nothing else to simplify. Even though there's the 2 in common, the 2's in the radicals are inside the radicals, so you can't take them out and reduce them with the 4. So that's a simplified fraction, and that's an exact answer because it's not decimal, so let's leave it like that. Okay. So letter B, now here you're in radians, but you want to find two values that either add or subtract to get you 7 pi over 12. So obviously we're going to use sine. Now if I think about two values that give me 7 pi over 12, that would be like taking pi over 3 plus pi over 4. So for that, if I change those to 12s, pi over 3 is the same thing as 4 12s, or 4 pi over 12. Okay? Pi over 4 is the same thing as 3 pi over 12. So then if I added those two together, it gives me 7 pi over 12. Okay? So now I've got my two values. I know what pi over 3 and pi over 4 are on the unit circle. So now I can use my sine addition formula, which is going to be sine of x plus y equals sine x cosine y plus cosine x times sine of y. So sine, remember this is your x, that's your y. Now for the addition ones, here's a trick. It doesn't matter what order is in, okay? For the subtraction ones, it kind of matters because the angle subtracted in different directions is going to be different. Like 30 minus 45 is negative 15, not 15. But pi over 3 plus pi over 4 is the same thing as pi over 4 plus pi over 3. Okay, so that doesn't really matter. Okay? So sine of pi over 3 cosine of pi over 4 plus cosine of pi over 3 times sine of pi over 4. Okay? So now I want to insert those values in. So sine of pi over 3 is the square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Plus cosine of pi over 3 is 1/2. And sine of pi over 4 is square root of 2 over 2. Now if you notice, it looks very similar to the problem we just had, because I get square root of 6 over 4 when I multiply, and square root of 2 over 2 or 4. So that gives me square root of 6 plus square root of 2 over 4. Okay? Now, for these addition subtraction ones, for the cosine and sine ones, they'll look pretty similar to each other. Just because you're using the same ratios, and since they're kind of like attached to each other, like they're the complements of one another, so they're going to kind of look the same no matter what you do. So don't worry about it. Tangent will look a little different because you're using its sine over cosine, so those values will look different than the cosine and sine ones, but they're still all the same. Okay, let's move on to the next one. So let's find the exact value here. Now, sometimes you're starting out in the subtraction addition formulas already, and then you need to figure out what it was to begin with, and then use your unit circle to figure it out that way. So sine of 20 cosine of 40 plus cosine of 20 sine of 40. Okay. Now here you can easily identify what your two angles are. 20 and 40 are your x and y. It looks like, looking back at our formulas, it's a sine function, and because it's a plus, that means they use sine of x plus y. Okay? So just looking at those two things, so because it's alternating sine and cosine in both terms, and because there's addition sign, that's what leads me to believe it's sine of x plus y, not any other one. Okay? So now, using that, I can rewrite this, plugging in what my x and y are, so I can say 20 plus 40, just coming from right there, and then simplify that, so 20 plus 40 is 60. Okay? So sine of 60 is square root of 3 over 2. And so that would be my answer. Okay? Let's try another one. So for cosine 70 times cosine 80 minus sine of 70 times cosine of 80, it looks like, I messed it up. So let's make this right. Okay? So sine of 80 at the end there. And it looks like that the 70 is x and the the 80 is y, because of the order. That's all I go off of. If you go back to the values, x is always first, y is always second. Okay, so that's kind of how I figure out which one's which. Cosines are multiplied to each other, sines are multiplied to each other, so it must mean it's a cosine function. And because they're using minus here, remember for the cosines, it's always the opposite. So since they use minus, that must mean it's a plus cosine function, so an addition one. So I should be taking the addition of x and y for my cosine. So cosine of 70 plus 80, and that gives me 150. And the cosine of 150 is the negative square root of 3 over 2. Okay, so that's what they're looking for those ones. Let's do a tangent one, because we haven't seen one yet. Okay, so here, for your tangent functions, they do the same thing. Now for the tangent ones, the trick is, obviously there's tangents in it, so it must be a tangent, addition, or subtraction. And look at, so if it's plus, the top one's going to be plus. If it's minus, the top one's going to be minus. Okay, and then the bottom one's always the opposite. Okay, so if I look at this letter C, I have a minus, so that must mean that it's a tangent of a minus, and it looks like, because remember it's the same order for tangents as well, this has got to be x, that's got to be y, because of the order, so tangent of 4 pi over 9 minus pi over 9 would be the trig function that I use, and subtracting those two gives me 3 pi over 9, which reduces to tangent of pi over 3. Okay, so then for that, sine over cosine, so then sine is the square root of 3 over 2, cosine is 1/2, and multiply by the reciprocal, that goes away, I'm left with square root of 3. Okay? And that would be my answer. Okay, so that's kind of what they're looking for when they're saying exact values. Either they want you to use the formula to like punch it out, or take the formula and take it back to its beginning roots. Okay, have fun.